Vishnu sir.
Sir, we can, shall we start?
Yes, yes.
Okay. So, good evening to all of you, and sorry for the half an hour delay due to some personal reasons that I had to meet. So, we are going to discuss something related to what do you call basic calculus. So, just by introducing the definitions of calculus, I think there are not many things to actually discuss. We will try to do some problems also, which we are actually supposed to do in tomorrow's session. Maybe we will go to that particular problem side also, and we will see that if we can do more problems tomorrow. So, to start with doing things in calculus, the very first thing that we have to understand is how to take limits. Taking limits, and after that we need to find how to differentiate, how to find higher order derivatives, and of course partial derivatives are also there, and after that we have integration, and definite integral is there, and probably indefinite integral is also there, and some problems like finding area between two curves, etc., is there. So we'll start with defining limits first of all, and after that we will go to slowly expand the scope of our problems, limit, and then checking continuity, and then derivatives, etc. Okay, let me start sharing the screen. Okay, so I have already shared the window, already shared the Google document in which I am copying and pasting the commands. So the very first thing we have to see is how to find limits. Limits of, another thing is that we need to be really careful about finding limits of our own defined functions, because we already know, we have already seen that the existence of limits at certain points which are for functions which are not very familiar to us can be a little bit tricky. So even Sage may fail at that particular point. Okay, we'll try to see if we can, if we are able to solve such problems or not. So first of all, using some standard functions, we will try to find some limits. So the very first thing probably we can try is the constant function itself, or let us try to define f of x to be a function. F of x equal to, let us see if we can differentiate this function, f of x equal to 1, and limit. Now we have to define from where the function we have to take, the structure of the limit command is the function we have to take, and the point at which we have to calculate the limit we have to specify. So the structure is basically f at x equal to 1. This is how we do, or x equal to 2 say. So this essentially means that limit of f as x tends to 2. So let us see. The result is just 1. Now let us try to modify the function. So let us try to modify. What should we give? Maybe instead of that, okay. Now what should I give here? Suppose that we give f of x is equal to sin x, and see, as x tends to 2, what is this limit? This x is going to sine 2. Now I think because I just use this, okay, that is required also. Or now one more thing I will try of a polynomial. Directly I will give it here, x square minus 1 at x equal to 2. Okay, we are getting, because of that f of x equal to that notation, I think there is some with the previous versions of SageMath, this f of x equal to used to work without much problem. Now it is actually giving the limit also as x going to 1. I don't understand why it's like that. Maybe if I give just f equal to 1, probably it will take it like that. But these things are happening with user defined functions. If you are using polynomial functions or combinations of certain non-functions, functions which are that are known to SageMath, this problem is not actually happening. Okay, anyway, so otherwise let me just define f equal to x square minus 1 and try with f. Here also this is fine. Maybe I should change the notation f equal to 1 instead of fx equal to 1. Maybe I can do this. The x dependence is not there, sine 2. Yeah, this is working perfectly. So just that name is enough. F of x equal to, there seems to be some small difference. You are you are assuming the argument to be x, or you are defining, you are taking a value of f of x, what exactly it is. I think Sage is getting confused because of that. You can probably drop that f of x. Now, let us take something else. This is not required. Directly we can put x square minus 1 by, or okay, by x minus 1 at x equal to 1. So what is the limit here? We know that it, according to our own, so what as human beings we try to do is we will try to cancel this x minus 1 from numerator and denominator, so that x plus 1 only will be remaining there. So exactly the same thing is happening here. Okay, so I am updating the Google document with all this. Updated. Okay, the Google document is now updated. Now let us try with something else. Limit 1 by x as x goes to 0. It says infinity. I am not very sure about that thing, because as x goes to 0, it depends on from where exactly it is, because if it's going from the left side, it's going to be all negative values and probably it's minus infinity. So that doesn't matter anyway, it gives infinity, that's it. It gives the only positive limit in that case, it seems. Now 1 by, okay, these things are quite familiar to us. Now sine theta, sine x by x as x tends to 0. We know this is a very famous limit. That's equal to 1. That's also correct. Now, can we give infinity itself? Limit x 1 by x equal to, I don't know what symbol I should give. I think OO should work, plus infinity. X goes to infinity, that's 0. And if I give minus OO, that's minus infinity. So the symbol is not 0, 0, it's OO. Looks like infinity, looks like, more or less looks like infinity. Okay, updating the Google document.
Sir, can you share the Google document link again?
I haven't shared.
I have joined another device and the link is
Just let me just see. Yeah, I have shared. I'll do that once again. I have already done that. Yeah, see it once again. So limit 1 by x as x tends to infinity. That's here. Remember that if you are putting the same limit command, two limit commands inside the same cell, you need to probably put a print also. Like this. If you are giving here itself, only the final output will be otherwise visible. So use a print. If you want both the outputs to be visible, otherwise only the last print will take the effect. Only the output of the last print will be shown. Okay, now let us try to see x into sine 1 by x as x tends to 0. What happens? Will Sage be able to compute some such trickier limits? X star sine 1 by x. We know that sine 1 by x, when x goes to 0, though 1 by x goes to infinity, either on both sides, minus infinity when it comes from the positive side, and plus infinity when it comes from the positive side, and minus infinity when it comes from the negative side. X into, because of that sine 1 by x, since it's bounded, finally the effect will be actually provided by x, so that the limit is 0. Yeah, that's also computed efficiently. That's fine. Now To find the left and right limits, what we have to do is that we need to just specify its plus limit or minus limit. Okay, x goes to a plus or a minus. Exactly the same thing we have to do. Let me update Google document. Yes. Now the limit. Okay, I am not using the print command because I will be typing only one command per cell. But if you are typing all the commands in a single cell, you need to use print, as I told already. Limit. Okay, the floor function, we will take the integer part function. So floor of x as x tends to x equal to 1. At each and every integer point, we know that to the right of 1, the floor of x will be 1. To the left of 1, floor of x will be 0. So if you try to find the limit at this point, what we get is that this is undefined, right? This stands for undefined. The limit is not defined for the floor function at integer points. But on the other hand, if you give this to be equal to 0.5, that's defined. Now to find the left right limit, what we can do is specify the direction as plus. So when we specify the direction as plus here for this function, we will be getting plus direction means from the right, so this is going to be equal to just 1. So that's correct. And if you use the minus direction, so this is just a type of keyword. Minus, plus, all these are reserved, so we are getting it to be equal to minus. So let me update the Google document with all these. Floor. This one also. And now, okay, updated. Save. Now we can say that these two are not equal, right? If we ask if these two are equal, Sage will simply say suppose we equate these two and ask if they are equal or not. Double equal to means equality, and the answer is sorry. That's probably not working. 0 equal to 1. It's simply printing. It is not actually considering it as, okay, we'll do one thing. If we change it equal to, okay, if not equal to, I think that's better. If this is not equal to, we will print limits are not equal. Okay, otherwise we will simply take a to be equal to 1 and we will evaluate it at a, not equal at a, not even to be exact, like left and right limits are not equal at a. Okay. So the Google Sheet is updated now. Yes. Yes. Let us see whether that input is working. You want to use the input command. Okay. Int or float. See. Didn't it print? Okay. What did I do exactly? Enter value. A is accepted. Enter value 0.1. Yeah, enter key, not I pressed shift enter. Okay, that'll work. So now the continuity also can be actually checked, but the only thing is that the existence, if it's a number or not, we may have to verify. Okay, assuming that even infinity, it's giving even infinity as a number, and assuming that the value of the function exists at that particular point, we can check. We can actually define. We can write a small program which will evaluate whether function is continuous or not. A small program. It's just we need to just club all these things. Suppose that we take. Okay, it's already there. Limits are not equal, and therefore we can say that the function is not. Okay, we cannot say just because of that. Even if the limits are equal, the function value need not be equal. So the function value also we need to evaluate, right? So maybe if we check all these things, 0.5. Maybe we can just take this as left limit minus left limit is here plus right limit. I am using the word the variable name as LL and RL. If LL equal to RL and LL equal to the function value. So maybe we can write f is equal to floor of x and use f everywhere, so that the program will become somewhat general, and LL equal to f of a. What you can say is the function is continuous at this point. Otherwise we can say, didn't I close that? LL equal to RL and okay, bracket is missing. Otherwise we can say the function is not continuous. Which says the function is continuous at A because it's not continuous. This is a small program, and if we change this to sine, the function continuous at this point. Yes, it's continuous, which is the point we are taking. Suppose that we take 0, and suppose we take this to be equal to 1 by x. Will it work? 1 by x, the function is not okay. The function is not. The limits are okay. Limit probability will say okay. Let us even see that function is not continuous. Why? Let us try to see what is the value of LL. Okay, minus infinity and plus infinity. Therefore, it's trying to equate these two values, and of course, it's trying to find out 1 by x, and 1 by x also f of 1 by x. It says, sorry, one print is required. What is this into mark? F of 1 by x. Oh, 1 by a we need. So division by 0. Okay, that's also happening. Anyway, I think it's failing at this RL. So what happens is that it's failing here itself. But if you are putting this LL equal to FA condition in the beginning, the problem is that it will try to see, it will try to evaluate f of a, and it will fail and it will create an error. See here, without going into this part. But previously what happened is that the first if itself, first condition of the if statement itself is failing, and therefore it's not at all evaluating this. Okay, so in this particular situation where you expect division by 0 to be there, you need to do some extra programming. Okay, that we will probably discuss later, because that is not, you have to catch the error, you have to try to catch the error, and you should show your own error message. Otherwise, such system error messages will be appearing, which is very confusing to most of the users. Okay, of course, the last line is definitely there. There is a method called try catch, try exception, like that, where exceptions like division by 0 occurs, we can capture that error, and instead of throwing these long error lines to the user, we can show a very small informative message to the user. We will try to do that later. Anyway. So it's always better to see that left and right limit first. And of course, if the left and right limits are itself creating some division by 0 error, most probably division by 0 error is not going to happen, I guess, because when the limit is being taken, the division is not actually happening there, but instead of that, limit is being calculated. So it is better to just keep this function evaluation towards the end. Okay. Copying and pasting to Google document. That's a full program for evaluating continuity. So in the same way, we can try to define, okay, piecewise function previously we defined, and I don't know whether that piecewise function will be working here. Piecewise function also can be used. I will try to see. Piecewise. Piecewise function, let us define the piecewise function. We have to define it as inside a list we have tuple. Okay, f equal to piecewise as a list. Now suppose that we take closed interval 0 to 1, 0 1, not closed interval, right open, 0 1. At this point, let us define it to be equal to just equal to 1. Okay, let's see. So piecewise function. So it is a list in which we have to specify tuples. This is a list first of all. So this is the first tuple we have. Not here. Okay, is it fine here? It's mismatching basically because of, okay, this one and this one. This one is matching with what? This one is matching with this. So I guess that this is correct. Now it's not complete. Okay, one more. Within we will define 1 2 2 as 2. Suppose we define like this, and let us see if it okay, some bracket mismatching is still there. Okay, let me just see. So this is 0 1. Okay, this is the definition of the first one, the first piece, and this is the, okay, this is not required. This is the definition of the second piece. Now as a list, how many brackets I am putting here? This is matching with what? Let me just see if it's does not match opening parenthesis. Okay, let me just see. This is a tuple. The interval. This is the interval I am using. Open, close interval. So this is entirely a tuple. So that's here. Now the next tuple is here. So this is not probably required. I think now it's probably matching. Hey, what is the mistake that I'm doing? So list. Okay, let me just try to do it once again. Okay, so I need a list. Okay, in which I am going to define tuples. First tuple, this is the first piece. Second tuple, this is the second piece. So in this first tuple, I am defining open interval 0, 1. Let me define open interval 0, 1, and at open interval 0, 1, 1. Okay, initially I will define it to be open interval just. Now 1, 2, I am defining it just to be equal to 2. Now let me just change this to close interval. This to close interval. Let me see. Hey, why is this fellow still creating the error? Where am I doing? Am I doing some mistake here? Okay, let me just see. I think he is not really interested in mixed brackets. Okay, that's the problem. Okay, so opening, closing. Okay, so in that case, I will do something else. So to define it at just 2, I will just use the interval close interval 2, 2. Okay, close interval, not close interval 2, 2, sorry, 1, 1. At 1, 1 also I want 2. Will it make sense? Domains must be pairwise disjoint. Okay. On 0, 1 it's 1. On 1 it's 2. On 1, 2 it's 2. Okay, that makes sense. Now I'm trying to evaluate the limit if it's actually evaluating or not. Limit f at x equal to 1 in the direction plus from the right. From the right it's going to be equal to 2. What is this? F equal to f at x equal to 1.
Second interval is 1, 1.
Sorry?
Second interval.
This one?
1. Yes, sir, yes, sir.
I defined it to be 1, 1 because I wanted to include the point 1, 1 also.
Oh.
Because the left open, right closed types of intervals are not being accepted by the piecewise function.
Oh.
Yeah, piecewise is accepting either open interval or closed interval. Or to include a single point, what I can do is define a closed interval using that. Okay. So direction is plus. So it is not interested in computing the text called. Where is that error? Where is that error? Where do this start? All these things starts at which point? Limit f x equal to. He is not interested in our own defined functions to compute the limit. That's surprising. User defined functions. Maybe I can use what should I do? So let us just see limit. Piecewise function and limit. Just searching if Sage is accepting that. Okay. Okay, I need to. So the suggestion is that I need to use something slightly different tool available in SageMath itself. Okay, let me just try. I'm getting something from the internet to solve this. Maybe. Oh, not implemented. What is this? X equal to, for that I need to use limit, not lim. Okay. Even that is not correct. So I define limit x equal to 1 by 2. The spelling is correct. SymPy I used. Maybe I should. That should not make a difference, but I am just trying.
Sir, for limit LIM.
No. There is another alternate command also, but both these commands are not actually working. One is using, see, for computing limit, Sage is actually getting the help from another mathematics software inside that called Maxima. Okay. So LIM is coming from Maxima and LIMIT is coming from something called the symbolic Python. So there are different libraries available in SageMath. So I was trying to make use of this limit function available in symbolic Python to evaluate this, but that is also not, that also doesn't seem to, okay, I think because, okay, there is no X notation anywhere, right? Okay, that's a constant function. That's another mistake that I have done. This is entirely a constant function I have defined. Maybe I should define, there is no X dependence at all anywhere. So I will do one thing. I will define, so x equal to 1 or x equal to x square, both these things are the same, right, at 1. Okay, now let me just try to find this itself, x equal to 1, still. Okay, once again. No, that is still, I think that's, don't know how to calculate MR where 2P goes to not implemented. Something it's unable to, it really does not depend on X after simplification. Okay, maybe I will put one more X here. Will it work in that case? No, it seems that there is some problem still. Okay, let me just copy one example from the internet and see if there is something wrong with my define function. This is F. So I am taking another example from the internet. It is this function. Now trying to find limit of F. So what are the pieces? There is a one piece anyway.
and it is square brackets are used, and earlier we have written small brackets.
Sorry?
So here you have used square brackets.
Okay, so?
Earlier we have used small brackets.
Oh, that's okay. I'm just trying with an example that's already available in the SageMath forum. This is a different one.
Outside this. Yes. Yes.
This one?
Outside this. Yes, sir, yes. I think
so I think both are working. So
here it was not working, so.
Oh, is it so? Okay, let me just try to change it to. You wanted the open bracket instead? Previously we were using open bracket there, right?
Yes, sir. Yes, sir.
Okay, let me just see. But I think in one definition we are using it as a tuple, and in another definition we are using it as a list. I was thinking that both should work, but anyway, let's try to see that.
Oh, yes, yes.
Both these things are working. There is no difference. List is also fine. But the thing is that this is not working completely. So limit of the point is not in the domain. So for the piecewise function, if I want to, let me just see once again. So piecewise doesn't seem to support. Okay, let me just at least see if this piecewise function supports plot or not. So these types of functions we may have to encounter once in a while. Plot this function within the range 0 to 2. 0 to 2. Will it work? Okay, the plot function is working, but the limit is not working. Piecewise. Okay, I will depend on another function provided by symbolic Python expression at 1 by 2 x equal to 1 by 2. I am just copying pasting this. So where is that definition? Let me just take this once again. I'll update the Google document after this. So once again, this is the definition. Now limit of f of x expression at so where is this 0 to 1? Okay, so let us take it to be 1 at x equal to 1. So the expression at 1 essentially means that the value of f at 1, okay, we just see if it's working. So something that we have just now encountered is a new keyword kind of thing. Okay, let me just update the Google document, and after that I will try to explain what it is. We'll try to see some examples also using this expression at. Let me just update. I have updated the Google document. So this algorithm SymPy is not really necessary, and this can actually go to the left side, left margin. None of these things are necessary. Only this much is necessary. Okay. Okay, so to understand this expression net, let us try to see that certain parameters associated with this piecewise function, because piecewise function is something that we are going to encounter at several places. Maybe we can do one more example before going to that the finer details. Just trying to imitate exactly, we will just copy and paste exactly the same kind of expression. So let us define this to be, what is the previously defined function? We encountered an error somewhere. Previous function was, this is the function. Okay. Now let us try to evaluate the limit at this point. So here we wanted to evaluate the limit at x equal to 1 once again. That's coming to be 1. Now let us suppose that we take 0, 1 to be x and at 1, 1 to be sin x. We are getting this to be equal to 1. Is it correct? Limit of fx at x equal to 1, what is that? Okay, let us try to see this around. Expression at 1 is sin 1. So expression at essentially means that we are getting the function value at that particular point. Okay, that's it. The function value at that particular point. So when we apply the limit, limit of, okay, so essentially what happens is we need to interpret it like this. So expression at 1 essentially means that at the point 1 what exactly the piece corresponding to f is, that's it. There is nothing else. So expression at 1, 0.5, it will give x. Okay. So it is not essentially computing the limit correctly, but instead of that we are actually specifying that which limit will be taken. So now expression at 1, it gives sin x, because at the value 1 the function is sin x. Now expression at 1.5, it is x, or let us modify it to x square. Okay, so if you want to find out the left and right limit at a point where the one particular piece is ending, so what we are supposed to do is we need to just evaluate it at slightly to the left of 1 and slightly to the right of 1. Otherwise the Sage itself is not actually taking care of the left piece and right piece somehow. Okay, for that there is one more thing that we can, one more possibility is there. So suppose that we have defined f to be this. Okay, suppose that we want to list out all the expressions. F dot So expressions defining f. So what are the definitions of f in different pieces? So if you go for this, you'll get x, sin x, and x to the power 2. So to automate the process, to check what exactly is the value, what exactly to the right of one particular value, what exactly the function value is. So what we can do with that? So that's the question. So suppose that we want to evaluate the limit at 1. To evaluate the limit at 1, to check the continuity of the function at 1, we need to evaluate the left limit. So it essentially means that to the left of 1, okay, the value, the expression is x. We need to use the expression x at 1. At 1 we cannot, to the left of 1. So we need to evaluate the left limit at x equal to left limit at x, right limit, left limit as the limit of x, right limit as the limit of sin x. Okay, that is essentially what we are supposed to do. But how do we automate? That's the question. So how do we find that this is actually an endpoint, and that endpoint corresponds to, so 1 is going into which expression? That's the question. So 1 belongs to which expression? So that's what expression at is. Okay, expression at. So how do we go to the expression just before that?
Here sign 1.
No, ma'am, what I'm saying is, see here, suppose that we want to evaluate the limit at 1. Okay, let me make my my question clear. So here I am also wondering that how to exactly evaluate this. So suppose that I want to evaluate the left limit and right limit at 1. Okay, that's the question. So
Yes.
to evaluate the left limit, I should take f of x equal to x.
Yes, sir.
To evaluate the right limit, I should take f of x equal to sin x. Maybe I can just change it to, in the entire domain, let me change it so that there need not be 3 pieces. 2 pieces, that's more than enough for understanding. So 1 to 2. Okay, so when I am feeding the value 1 to find the limit, I should understand that 1 is included in sin x. That's quite clear, because expression at 1, I will get that function to be equal to 1. Sorry, sin x. Fine. Let's just see this.
So we have to find left hand limit.
No.
Means minus, direction minus.
No, what I'm saying is expression at 1, it will automatically give that to be equal to sin x. Okay. Expression to the left of 1. So how will I determine, how can I say that to the left of 1 at each and every point I need to look at x. I need to use the x function itself. How can I automatically say that? That's the question. Now I can do that because I know the function, I can see the function. So to solve this, to determine the continuity at this, what you call x equal to 1, what I can do is I can just take a small value to the left of 1, for example, but that small value itself is not very easy to determine. So suppose we find the limit, okay, left limit and right limit, we can of course, left limit we can find it to be, as we have already done, limit of f of x at 1 minus epsilon, or let me just define epsilon to be very small, 0.001, something like this. Okay, I'm just trying to do something. Epsilon. So left limit is f of the expression to the left of 1 minus epsilon, expression at 1 minus epsilon, which is to the left of 1, definitely, and x equal to 1. In the direction minus. Does this make some sense? So are you able to understand what exactly I am trying to do? So
Yes.
you can probably guess that what I'm doing here is I am taking an arbitrary point, a small which is to the left of 1 at a very small distance, so that I'm taking epsilon to be very small in such a way that it will not cross the left boundary of that interval. Okay, that left boundary is 0. So I will be getting, using this command, I will be getting the expression at 1 minus epsilon to be equal to x. So at x equal to 1, I am trying to evaluate the left limit. I don't know whether this will succeed, because x equal to 1, it may again say that the expression is not actually equal to x, but the expression is sin x. I am trying. Okay, let me just try. I'm just trying to see if it will work. No, that's also not working, because sorry, what happened here? X is an invalid argument for print. Where is that print? From the left. Okay.
Limit.
Sorry.
Print limit of x.
Oh, I have printed the limit. Okay, sorry. That's completely wrong. Yes, correct. Thank you. This is limit, right? Just limit. Or lim. Lim, I don't know whether that will succeed. Okay, anyway, I'll try with that. Am I getting the correct thing? X going to 1 using the expression x. It's okay, right?
Yes, sir.
Yes, sir. Yes.
So that's correct. Now RL equal to, exactly in the same way, RL equal to expression at 1 itself, right? Because I know that, or 1 plus epsilon also I can take, there is no problem. It's such a small value. But in the direction, plus RL. So sin. And the function value also we can evaluate. F value, once again expression at okay, let me just see once again. So this is expression at, so I need to evaluate, right? So how do I evaluate? I think I can substitute for x equal to which is that value I wanted at 1, right? I think I will just I substitute like this. I don't know whether this will give me some correct result. Okay, I am getting the correct thing, right? So here what I did is fx expression at 1 plus epsilon, this will return the expression of f in the interval 1 plus epsilon, which is sin x. Now in sin x I am substituting, instead of x I am putting x equal to 1, which is essentially sin of 1. That's it. So now if all these values are equal, LL equal to RL and LL equal to F value, I will simply print function is continuous at, okay, I have not specified any value here, I have not used any A here, or otherwise else okay. So I think this is a very good exercise for us, but the only thing is that we need to carefully choose epsilon here.
So in the F value expression, do we have to add that 1 plus epsilon?
Where, which line?
F value equals
Here.
F value, no, F value.
F value.
1 plus epsilon.
See, you are actually okay. That okay at 1 also we can do that. Right. That's if you are evaluating it only at 1, I think this 1 is good enough. Even that's also not required, I think. We can automatically also put is what I think.
Yeah.
Substitute, because it should automatically guess no. Yeah, that itself is good enough. Thank you. That's enough. We can substitute, because function definition, it must at least understand that the value of f at the definition of f at 1 is actually sin x. Right, that's correct. This much is enough for us. Okay, let me just update the Google document with all this. Update it. You may please try these commands. I'm just taking 1-2 minutes for so that you can have a look at all these things. What are all the things we have done? Expression is a new thing that we tried just now. And expressions is another thing that haven't we seen that expressions? Okay, expressions is also here. F dot expressions will list all the component functions in that piece. And of course, one more thing is there. I would like to tell that also. Domains also we can write. So the pieces. Domains. Yeah, in that way, actually, we can do one more thing. That we can actually match here, right? X corresponds to 0, 1, sin x corresponds to 1, 2. So in this way, we can just ask to which part actually 1 belongs to. Okay. So something like this. Suppose that we are given a value a equal to 1. We want to see that to which part this actually belongs to which number. See, here we can see that this is the 0th piece, this is the 1th piece, because counting starts at 0. So suppose we ask in which piece this 1 belongs to. Maybe all expressions. Let me put it here. All domains. That's a variable. I'm just storing these two values to these variables. All domains. Now I know that I want to see where this a equal to 1 belongs to. Okay, still I cannot actually make out what exactly is the left of that. Should I go to the left of that particular value or right of that particular value? I don't exactly know. Okay, anyway, if it belongs to one particular interval, I need to just look at 1 minus epsilon. Okay, that's not going to make that's not going to give much insight into which one I need to actually try. All the domains are here. So how do I know that 1 is the left endpoint of, I can definitely get 1 to be in some interval, but how do I know that 1 is the left endpoint of some domain? Maybe once again I have to use this epsilon itself, because if I subtract an epsilon and from that 1, and if I jump into one domain before that, then I am at the left endpoint. Okay, that's not going to give again I may have to use this epsilon. There is no other way. That's not going to be much useful. Okay, what I thought is something else, but that's not going to work. Print expressions, domains. That's it. So these things are applicable for the piecewise definition. Right. Okay, there is one more useful command. Okay, that's probably going to be useful for us. the endpoints can actually be determined. So that answers. What are the endpoints? Yeah, this is going to be useful for us, because if we get 1 to be the endpoint of the first one, then we can ask whether 1 is in the first interval or the second interval. If 1 is in the second interval, what we will do is that we will take the expression before that as the definition of f to the left. Okay, this is going to be useful, and I think it's going to be a very good exercise if we can try to write a code, a small piece of code, in which without using that epsilon, without using that 1 minus epsilon. See, the problem with using 1 minus epsilon is that you need to choose epsilon in such a careful way that 1 minus epsilon should not cross the left boundary of the left interval. Okay, 1 minus epsilon should not cross the left boundary of the left interval. So that actually is a little bit confusing. You need to really think a little bit. But instead of that, can you say that 1 is in which interval you can locate, and to the left, if it's the endpoint, using the endpoints command, we can actually locate that, actually determine if it's an endpoint or not. Once you determine if to be an endpoint, you know that it's an endpoint. Therefore, you can find out if this endpoint is in which domain. Correspondingly, you can take the left limit and right limit. I think you can try to write a code for implementing this program. Without using that epsilon subtraction. Okay, just try. I don't exactly have a complete idea about that thing, but I think it's going to work. I don't have a complete idea of what to actually do, but you can try. Okay, these 2 lines also I am updating. Done. Yes, please try these commands once, and after that we will go to one more idea about this piecewise function. And let us try to do one thing. Yeah, I wanted to actually define. I started all these things with the intention of defining some familiar functions like the Dirichlet function, which says that at rationals. So we are defining it on the set of all real numbers. At rationals, we define it to be 0, and irrationals we define it to be 1, or the other way, whatever. So we can probably try to define this piecewise function in using that that definition, and try to plot it also. How will that plot look like? That will be interesting to see. Okay, let's try to define. Now trying to define the Dirichlet function. Oh, but the problem is that how do we know what exactly an irrational is? We don't have a standard set for that. So we just have we just have this rationals. We have QQ, but irrationals we don't have an expression. But what about PP? No, I is someone it's mentioning. No, this is also not right.
The last class we have not got this one. After that we have done RR minus QQ.
RR minus QQ didn't work, right? RR minus Q, I think it failed. Or maybe this is not. We cannot take RR to be an entirely. It's not exactly a kind of a set. It's something different. Sage is defining it to be a rational. Sage is defining it to be a real field or real ring. It belongs to a class called ring, not actually a set. So our intention is to define Dirichlet function in SageMath. How do we do that? It's actually a function. So we essentially need irrationals, right? So maybe we can Q and N are fine, but Q and N is also going to create some problem because we need the sets to be disjoint, because otherwise piecewise will throw an error. And in fact,
complement function is there.
Sorry, complement. No. All these things, the complement, difference, all these things, all these kinds of operations we are defining on sets. But the problem is that RR is not actually a purely a set in SageMath. So I think that Dirichlet function probably we will not be able to precisely define using this piecewise function. Okay, that we have to probably see if we can define a set, probably we'll be able to do, but even defining, so otherwise we may have to define if it's a rational, if it's an irrational, but even that function is not going to make much. Okay, what we can do, okay, we can try to define our own function, but that our own function is not going to be compatible with, okay, our own function is not going to be compatible, that's what I'm wondering, with its limits, etc. So, Dirichlet function if we define, so how do we define? Return, sorry, if x in QQ, maybe we can return, if we define it to be 0 and 1, else return 1. But I don't think that this will work, because this is a single variable kind of function, and with the limits this may not be compatible, is what I am afraid. Okay, this should, else. Bracket is not probably necessary here. So, set 1, square root of 2 itself. So 0 and 1, that's definitely working, but what I'm wondering is the limit and all such things may not actually work. Okay, let us try anyway. Dirichlet x equal to 1. So it's unable to convert the function to a symbolic expression. So So okay, let me just try to define it as a symbolic function g of x equal to so let us define this to be, okay, I'm just trying once again. No, I don't think our own defined functions will be able to do that in certain properties. Our own defined functions are not getting accepted. Defined symbolic math function. Okay, that's not actually working. So I don't really see a way to come out of that problem. That defining Dirichlet function, definition is fine, but using it in the symbolic operations like see plot and all these things. Okay, plot, even plot may not work is what I think. List plot may of course work, but plot is not going to work. List plot, it's only asking for a few number of points, but all other things are actually asking for something, a function defined with some special extra character. That's why we are failing. Okay, that symbolic expression we are actually failing. Symbolic expression converting just 1 minute. I will try to find out one more way. Conversion of symbolic expression by algebraic converter. How to define? If we have a way to define irrationals, definitely we can. Irrationals, even numbers. Okay, we don't really know two disjoint sets. Primes, even numbers. No, I don't see a way out of that thing. Okay, we'll try to locate that thing if at all possible. Dirichlet function we can define like this, but that's not okay. Even the Thomas function, what exactly is the definition of that Thomas function? I think if it's m by n, if it's rational and m by n, its value is equal to n. Its value is equal to 1 by n, and otherwise it's equal to 0, right? So even for the Thomas function, I think it's going to be a little bit difficult, because for the Thomas function also we need to define something using this. Okay, so our own defined functions are not actually compatible with this limit expression. So this is our own defined function. But if we are defining f to be equal to not using def, this is actually the Python style function definition. Okay, is there any Sage style function definition? Is that what we have to see? Sage. So for defining one-line functions, of course, can be defined, but the Python definition, Python style def keyword, if you are using, then it's not perfectly working. Okay, let us keep that question for our discussion later. Okay, this is one more question. that we already had one question yesterday that we could not actually find a solution for that. That is filling the curve to y-axis.
Not visible.
Has it gone? Why is it going like that? Just 1 second.
Yes.
I am seeing it here. Is it not visible for everyone or?
Now not visible.
But it seems to be visible for others. I think it's a problem. It's a problem probably in, with maybe the net connection. Okay, so we will keep this as the second question that we are supposed to solve. So all these questions, what I'm thinking is that I will keep this as the questions for later to be solved, because all these things needs a little bit of searching and finding out the answer. So the question number 1 is that filling from the curve to y-axis. Question number 2 now is that how to define, how to use the limit command on our own defined functions. So there are 2 questions. Now I'm not spending much time on that, because otherwise we'll be wasting a lot of time on that thing. Now I'm going to differentiation. Okay, after this limit, now let us go to differentiation. In the differentiation also, definitely this user defined function is going to create the same type of problem, because differentiation, limit, all these things are actually provided by I think modules called maxima. Maxima will not accept user defined functions, because sin x and all these things, these are functions defined by maxima itself. Maxima is a module. Maxima is a kind of component software available in SageMath. Therefore, the function sin x, when you call the sine function, when you call the function x square, when you call the polynomial functions, all these things are available as ready-made functions in maxima, and therefore the maxima operations like limit, differentiation, all this will work on such functions. But when we are defining our own functions, the problem is that maxima cannot actually make our own functions compatible with its operations. That's why it's failing. So let us try to see if there is a way out to settle such things. Okay, so we will keep these questions for the future to be solved. But now let us go to something like differentiation. So we have seen now computing limits. Now let us go to differentiation. So differentiation, the command is quite simple, just DIF of sine of x, and if you do not specify any variable, since there is only one variable, it will be printed, it will be differentiated with respect to that the variable we are giving inside. So that's cos x. So directly a function anyway. So whatever I have done, I will copy and paste so that you also can have a look at that. I'll just copy paste, but this problem is not complete, of course. I have copied and pasted, but there is some problem with the alignment. You need to check the alignment. Left alignment is having some problem there. You please, while copying and pasting the code from the Google document, please be careful about this left margin. Okay. So this is differentiation. Now yeah, you can perform sin x plus cos x as well, and plus even x square. All this makes sense, and if you use the show command, you will get a much better output. Now even print, okay, x square x raised to 5 x and 2 if you give, oh sorry, diff is missing. So here you can understand that here I have taken the first derivative, which is 5x to the power 4, and if we take the second derivative, we will get it to be this. So x to the power, the function name with respect to which variable, 2. If you do not specify this x equal to 2, sorry, if you do not specify the variable name there, then also it's fine, there is no problem, since there is only one variable. Okay, since there is only one variable, there is no problem. But if there are two variables, this will create some trouble. This is,
If we use show command, then it will show x cube. If we use show command.
here.
In next 94. Yes, sir.
Yes. Yeah, show is actually for showing the what do you call it, a neat looking math output. So it's basically it's using LaTeX. SageMath is using LaTeX when you are using show. And in fact, you can get LaTeX command also if you want to copy and paste this code. That's also possible. See. Okay, if you use LaTeX and if you pass one computation command inside LaTeX, what will happen is that the output will be displayed as LaTeX code. Okay, that's also possible. So you can copy and paste this code within dollar symbol if you keep. So suppose that you keep it inside a dollar symbol. See, in fact, see, I'm just clicking on this. There is the cell can actually be converted to something called markdown. Okay, there are cell type, there are two options, code and markdown. If I use markdown here and if I use dollar symbol here, if I paste it here and run it, I'll be getting a neat math output here. There is no computation, right? There is no computation. It will be just displaying it exactly like that. But the thing is that you need to convert this cell type to markdown instead of code. Okay. Second priority, LaTeX code. And this is also quite valid. Copying and pasting to Google document. Now, if we have multiple variables, then you need to be really careful. I'm using only print or otherwise show itself. Differentiate sin x square y sorry, x square y is missing, sorry. Okay, variable is not defined. Still there is an error that no differentiation variable is specified. Therefore, if there are multiple variables, you need to specify that with respect to which variable you want to differentiate. Suppose x, you get it to be this. Now, in fact, you can differentiate it multiple times. Differentiate with respect to x 2 times. That's also possible. Second order derivative. So updating the Google Sheet, Google document, done.
So one question.
Yes, please.
While including the variable y, why is it required to make the y as a variable first?
Sage, if you are not declaring, x is considered to be something very special in Sage, and therefore even if you are not declaring x to be a variable, it is, if it is not defined to be anything else, it will be treated as a variable automatically, no problem at all. But otherwise, whenever you use an expression in SageMath, that has to be either a function, or it has to be a number, or it has to be a variable, right? So by var y, what we actually mean is y is a symbolic variable, not actually a variable with a value. Okay, this is a symbolic variable. not actually a variable with a value, because if we write y equal to 6 or 7, something like that, it is not actually a symbolic expression, it's actually a variable consisting of a value. But here, what you want is, you don't want to evaluate the value of y, right? You want to keep y as y.
So x is by default only considered as a variable.
Yes, yes, yes. Only x will be treated as a variable by default. That's it's a mathematician kind of philosophy, because most of the times we will not mathematicians. I think I have only rarely seen. I might not have seen anyone saying that let x be a constant, right? Do we ever say that x be a constant? I don't really think that it's a common thing. Most of the times we use it as a variable. X is a reserved name for variable for most of the mathematics purposes. I'm not saying it as a rule, but that's a convention. Okay, so whenever you want to use something else, you need to definitely declare it as a variable. You want to use t as a variable name, you want to use z as a variable name, whatever, you have to define it as a symbolic variable. By var, we are not actually declaring it to be a variable, but a symbolic variable. Okay. So this differentiation can be this is actually partial differentiation, right? So when you have multiple variables and you are differentiating only with respect to one variable, this is partial differentiation. Now you can if you want to differentiate using x and y, then what you have to do is, so x and y in the sense that, suppose that you want to differentiate first with respect to x, and suppose that you want to differentiate later with respect to y, what you have to do is that you have to apply this diff command multiple times. Here diff is applied once. Suppose that you are defining it once. Now suppose that you want to define it over y as well. So the first differentiation will be over x, second differentiation will be over y. Okay, diff is not specified. Diff, sorry. So you have to use diff 2 times. Maybe show is a better choice. Oh, sorry. Oh, this is differentiating with respect to x. Okay, that's correct. So this is the command. So it's updated. Now one possible question is that can we define vector valued functions also using this? For example, suppose that we define, okay, let us define t to be a variable, r to be equal to cos t, sin t, diff r with respect to t, again the same problem happens. So even for the parametric differentiation, what you have to probably do is just to take the parametric in the sense that, suppose that you have a vector valued function where there are components, you need to differentiate the functions separately. That's the only way it seems. So that diff command is not accepting such expressions for differentiating. So even if you use directly, what will happen? Suppose that you use it directly. No, this is also not going to work because this will not be treated as a function, first of all. This will be treated as two functions. Okay, this is not going to work. The only way is to take the components out and differentiate, because you know that R of 0 is there, R of 1 is there, you need to just iterate through all these things. So if you have several components, so you can find out using what you call the listing. Suppose that, okay, I will just try to show that this is an alternate technique, not exactly a complete solution, but we can solve it somehow. So suppose that this R has two components, we know. Okay, so suppose we call it to be the dimension, because there are two. This is in R2. Dimension of R is length of R. Length of R in the sense that, okay, let us see whether that is actually giving something sensible. Yeah, it gives 2. Now what we have to do is that for we need to differentiate both these, and we have to just put it back. R dash or R1 equal to, just take it as an empty list, then for what do you call F in R, R1 dot append diff, I don't know whether it will work, I am just trying, diff F, okay, even this is not necessary. So differentiate F here, essentially what happens is that we will take F for the first time to be cos t, so this will be differentiated with respect to t and will be appended, and I am expecting the result to be that R1 to be a minus sin t cos t. Yes, that's working. So this is not, maybe I can convert this into print. I don't know whether this will work or not. I'll try. Yes. R1 is an empty list first of all. This is not necessary. This is an alternate way. So essentially we are differentiating it component wise, but without looking at each and every component, we can automate that. So we don't have to take R1, R2, R3, etc. We are in a for loop. So for f in R essentially means that take f to be this function first of all. After that, append the derivative of f. So R1 append the derivative of f to this R1. R1 is now empty. So append this minus cos t and minus sin t, and after that take the derivative of sin t and append. That's it. And I convert that to a tuple so that it looks like again a vector valued function. As I told, this is not a complete solution, but this is a possibility. I updated the Google document. Okay. So differentiation is okay. Differentiation is that much only. We can differentiate any given function using this command. But yeah, there is one more long command also for this differentiation, which is instead of diff, we can, if you prefer, we can use this derivative. Both these commands are equivalent. Differentiate, will it work? No, that's not there. Okay, this derivative also will work.
Sir, what will be output if I differentiate mod x at x equal to 0?
Okay, let us try it. What's meant by this? Oh, at x equal to 0 we have not given, right? But it is only giving that the derivative of the absolute value function. So to the left of x, the absolute value function is going to be equal to just x, right? Sorry, just 1. Sorry, minus 1. Okay.
Minus.
Yeah, x goes to, so minus we have to take, so it's minus 1. To the right, it's 1 at 0. But derivative, there is no way to evaluate it at one particular point. Limit only we are evaluating. So what is meant by this? X plus x bar. What is meant by x bar? Differentiate with respect to x. What is this? X bar is not conjugate of x. Is there such a definition? X plus conjugate of x by absolute value of x. So that essentially means that okay, I think that's x plus x bar. So if you are taking the real valued function, absolute value function, I think it's a complex function. That's why it's giving that x bar there. So if it's a real number, then x plus x bar, it's going to be equal to 2x, right? To the left of x, to the left of 0. That's 2x. 2x by 2 mod x. So 2x by 2 mod x is minus x. So that's minus 1, right? To the right of x, it's going to be equal to x plus x again. That's 1. That's the answer is correct. But at 0, yeah.
Square root of.
Sorry?
Yes, sir. It is taking as complex number.
Yeah, it's taking as complex number. The answer is correct except at 0.
But sir, the mod x value will be that square root of the component of real square plus imaginary square.
Yes, that's correct. So what?
And the numerator will be that twice the real of x.
Numerator will
Because
be.
we are differentiating with respect to x.
See, you are. I think you are thinking about x is not actually x is considered to be a complex number, right?
Yes.
X is considered to be a complex number. Therefore, x is equal to y1 plus iy to say. So to the left of x, there is nothing called left of x, right? If it's a complex number, see the problem basically here is that absolute value it's the DIF of it's a real valued function. We are actually applying it on the absolute value function, which is a complex function. So in that case, what Sage is thinking that we have to think on that line. So what Sage might be thinking, absolute value of x is a function. Absolute value of x is a function. So if you take absolute value of z, okay, we are much more comfortable with that z notation. Okay, there is not much difference. I am not saying that there is any difference. So here, if you try to define with respect to x, that is not going to work because Sage doesn't know. Okay, let us try to do another thing. Suppose that if we define z to be equal to x plus iy, okay, then it's not going to be that the usual or otherwise can we define absolute value of maybe okay, real. Let's try with this real. Is there a command called real? A real part of x. So what it might be thinking, absolute value of x taken with respect to x. So that's a complex thing. Modulus of z, what is the derivative of modulus of z? At z equal to 0, is mod z a differentiable function complex analysis? Except at 0, so for checking if it's a differentiable function, we need to go through that CR equations and continuity, right?
Right.
CR equations, right?
Right.
So, okay, let us try to see. Using Sage itself, we can try to see that CR equations. So, suppose we define z equal to x plus iy. Okay, let us try to see what exactly is happening. Suppose z is equal to x plus iy. So, CR equations, if we need, the function is root of x square plus y square, right? F equal to square root x square plus y square, fine. Anyway, x and y are anyway defined to be already variables, but again, so what do you need now with respect to f? We need to differentiate f with respect to x, and so what are the sorry, there is no see, this is a real, this is real, right? So therefore v is 0 here, so this is just u, okay, and v is 0.
So absolute of z is not differentiable other than any other point other than origin, I guess.
Other than origin, but what we are trying to understand is why Sage is giving this answer, that derivative of absolute value of x is x plus x bar by 2x. See, this actually makes sense if you are taking the derivative to the left of x and x treated as a real number. This makes sense. Okay, I think I am correct. So if you are thinking of x plus x bar to the left, it makes sense. X plus x bar to the right of x, that also makes sense, by 2x, 2 mod x. But if it's a complex number, that's not actually making much sense. But it is still differentiating. It's giving an answer, right? This x plus x bar by 2x, 2 mod x. At 0, what happens? X plus x bar by 2x. So this modulus function is differentiable only at 0, right?
Actually, derivative does not exist.
Yeah, that's a wrong answer probably. What I think is that it's we are trying to differentiate a function, and Sage is giving something nonsense, is what I understand, or at least something that we cannot actually understand what exactly it means. It's giving a derivative. I don't know what exactly it is. Show absolute value of x. Is there any other function that we can see? Some crazy function like this, which does not exist, derivative does not exist? Can you think of something else so that we can see if that there also it's giving a wrong answer or not?
So what about 1 by x?
1 by x may not exist at all. 1 by x, it will simply show it as
Yeah, it will.
yeah, that it will take it as a rational function. That it will do. Minus 1 by x square. That's not a problem. So 1 by x, the problem is that it is not at all existing at x equal to 0, right? So, but absolute value function, the difference is that it is defined at x equal to 0. So these two functions are different. The second function is not at all defined at x equal to 0, therefore there is no point in asking for the derivative. But the first function, it's defined at x equal to 0, but it is not differentiable, but it's still giving. Not only that, the derivative for 1 by x is correct wherever it's existing. But the derivative for absolute value function, okay, wherever derivative is existing, this is correct. But at 0, the function exists, but it is not correct. But why it's still giving such a fancy answer is somewhat not understandable to us. It would have simply given 2x by 2 mod x or x by mod x. Here, x by mod x would have been a better answer, right? Instead of x plus x bar by 2 mod x. I think this is because absolute value function is considered to be a complex function, and it's trying to differentiate a complex function. That's what that is what is happening here. Or let us try to see abs and other properties. Oh, there is not much help available. It simply says the absolute value of the argument. That's so. If we use,
So if we write x belongs to R, means x is a real variable. Actually, it
see,
should take.
there is a small problem. X may be, we will be considering x as a real number, but the function ABS is a function that takes values from complex numbers. So it has some defined properties. So that we cannot modify.
So what the output says, does it means that this apps is a function of two argument, because it has apps of x comma some forward slash
X comma y.
x comma backward slash as per the way it is defined by the system.
But absolute value, it simply says abs x comma, but there is nothing specified here. There is something known as something called signature. I don't know what exactly signature means is. So okay, let us just so what else we can try there? Absolute value of 2 plus 3i, 3 star I. So what do we expect there as? That slash is not very clear what exactly it means. No, it's not very clear that what exactly meant by that symbol is. It's not specified also. Of course, we can guess that something is being passed, something is possible to be passed as a second argument, but what exactly it is not very clear. So the document, yes, documentation is doesn't say anything. Absolute documentation does not really say anything. Absolute symbolic, absolute argument, conjugate. So everywhere it's just given by one single number, absolute value of a number. That's it. Nothing else is anywhere specified. No, there is nothing. No other help is available for this function. So we cannot proceed any further, I guess. That's it. Yeah, the only thing is that absolute value function, its return is of course a real number, but it's taken as a complex number. Therefore, it's not very clear that even though the output value of absolute value is a real number, it's shown here. See, on apps, I think this diff is using some different technique for. See, diff is actually a function available in SageMath. Diff is now being applied to absolute value function. So the absolute value, how do we actually define for a real number? X plus absolute value. Okay, let us think of something like this. Absolute value is defined to be x root of x square plus y square. Okay, root of x square plus y square. So root of x square.
Yes, sir. I am also thinking that here SageMath taken that absolute value function is square root of x square, and after if I take that mod of x square root of x square, then I am getting this sort of output. It's not exactly x plus x bar,
Yeah.
but it is 2x by 2 of mod x.
Right. If you take a square root of x square, the square root function will take 1 by 2x, right?
Exactly. 1 by 2 square root of x.
1 by 2 square root of x square, and it's taking the modulus as the it wants to take the positive value. That's why it's taking it like that. But on the top of that, it's differentiating that x square plus y square, and x square plus y square, it is somehow getting it to be x plus mod x. Instead of getting it as 2x, it's taking it as x plus mod x. That's what confusing to us is. I think it's due to that the working in the internal working of the diff function is creating this confusion, I guess. We don't know exactly why it's taken like that. The diff function, it is defined in some way inside this SageMath, and the definition of the diff function is creating some kind of some what do you call confusing answer for this differentiation. I think that's the correct.
Yes.
That's the only thing we can say finally. There is nothing else. Okay, so let us just leave it like that there. Okay, that's the derivative is that much only. Now the integration is quite clear possibly. For integrating, we need to just use this integrate command. Integrate sin x. If we just give integrate sin x, what will happen is. So here we need to specify the variable. It seems integrate, spelling is correct, I guess. Yes, we need to specify the variable also, integrate with respect to which variable. For differentiation, this was not necessary. See, this what you call inconsistent way of defining functions is mainly due to the fact that many of the functions are defined by, or different functions in SageMath is defined by different people. So for diff function, they assume that if you do not specify a differentiating variable, and if only one variable is present, differentiate with respect to that particular variable. But for the integration, that's not happening, because probably integration, that function, the integrate, is actually defined by some other person, some other mathematician who has contributed it to SageMath. He wanted to define it like that. That's it. Okay. There is no exact answer that why x is required here and why x is not required there. This is the only reason we can give for that. Different people, they visualized different process with their own point of view. That's why x is required here, x is not required in the differentiation command. Now, just like that, we can give definite integral also. Suppose we give 0 to pi by 2. Only specify the range here. So minus cos x within the range 0 to pi by 2. So pi by 2 is 0. Yeah, that's correct. Now, as in the previous case, we can integrate multiple times. Again, you have to apply the integrate command multiple times. So integrate with respect to y is also possible. So integrate sin x plus cos y. of course, remember that we need to define y to be variable. Since I have already defined that, this var y command is not really necessary here. X will be always considered to be a variable without thinking much. Suppose we define it with respect to x. It's defined with respect to x. Now, if you want to give the range, that also we can give. Now, if you want to define it, integrate it with respect to y also, what you have to do is that you have to again integrate. Once again, you have to apply the integrate command. Okay, now one more useful thing for us is to in integration is that's known as a partial fraction, right? So partial fraction can be easily achieved using the partial fraction command. 1 by x square minus 1 partial fraction. I think partial fraction with respect to x is also required. Sorry. Oh, why is this happening like this? One by. Okay, let me just put everything together. Yeah, because otherwise I think a partial fraction that is being applied only to this x square minus 1. Show okay, let me just update the Google document with all these integrate commands. So integrate I have not updated for a long time. So definite integral, integrating with respect to another variable, and partial fraction. So I have updated the Google document with all this. I think now with this probably we did not do any problem other than checking the piecewise function and checking the points of discontinuity. So we will continue with more problems related to this differentiation integration. Like I think as per the schedule we are supposed to discuss maximum minimum problems tomorrow. So we will be going into that part and some numerical integration, indefinite. Okay, numerical integration and all these things probably we will keep for the problem part, because we will be anyway doing some numerical analysis related stuff later. So just let us just keep that to numerical integration. We will keep for that thing. So tomorrow we will try to discuss maximum minimum problems and computing Taylor Maclaurin's polynomial and anything else also, provided that we get some more time. Okay. If there is any question related to these things, I will try to answer. Otherwise, I will push all these things to a queue. We will try to solve all these questions. I will try to answer all the queries which are unanswered towards the end of this series. Thank you. If there are any questions, you may please ask.
Hello, excuse me, sir.
Yes, sir, please.
So what about we can say that directional derivatives?
Direction derivative, how do you define? So
how do we write the program for defining directional derivatives if we want?
I think we have one session dedicated for this vector calculus, right?
Yeah.
I think let me just see the workshop schedule. Defining on
In
function.
in that case, we can define divergence.
Yes, we can define all these things. We will be doing all these things, in fact.
Yeah.
So I think let me just
Yes.
see. I'm just searching for that that schedule. Where exactly that thing is? Vector calculus, Lagrange multiplier, calculus maximum minimum problem, kernel combinatorics, complex analysis, polynomials, abstract algebra, operation search. Okay, we will do one thing. Tomorrow we will try to do the maximum minimum problem as well as some little bit of vector calc. And I think the session after this actually consists of Lagrange multipliers and all these things, and definitely we have to define the gradient divergence kind of thing at that time. Okay.
Yes.
In the next two sessions we will be focusing on these two things.
Okay. Thank you, sir.
Okay, I will upload now itself the document that we have just now prepared. Otherwise, I will be forgetting. Now itself, I will update. Please check after 5 minutes. I will upload the worksheet now itself. So, if there are no other questions, probably we will.
Sir?
Yeah.
Yeah, regarding the installation process of...
Yes, the installation thing from your log, actually I could not find anything because the log is actually saying everything to be perfect. So I don't really understand from that log. So what I can do is that, so can you please do one thing? Can you please come online, say what is the time now? So at 9:30, can you please come online and we can have a live chat, because otherwise you will be sending these messages to me. I will be replying after 1 day. Is that fine?
Sure, sir. Sure, sir.
Please, my email address is it's with you. And
so you can send me the Google link on my email.
Sorry?
I can't hear you, sir.
Oh, what do you exactly want? My Google ID, Gmail ID.
Yeah, I have. Yeah. So shall I share the Google code on your email ID? Or?
Yes. What we can do is that we can have a meet, Google Meet. You please send me the link at 9:30. Is that fine?
Yeah.
At the same email address at which you are sending the emails.
Yes.
Okay, 9:30 we will just sit together and try to fix it.
Thanks a lot.
Okay. Thank you. So probably, yeah, please.
So thank you very much, sir.
Thank you very much. So we will meet tomorrow. We will meet tomorrow at 6:30. Sorry, 6 o'clock. Thank you.